Hey guys, welcome back. In this video, we will talk about Hibernate association and we will talk about unidirectional and bidirectional one-to-many mapping. And for that, let's see a table structure between order and product. So the relation is one-to-many, means the order holds multiple product, where the order becomes the parent and product becomes the child entity. And for that, the table mapping would be like a product table will hold an order ID and this order ID be the foreign key representing to or pointing to the order underscore ID, which is the primary key of order table. Okay, let's start with unidirectional one to many. Here, the parent-child relation will be one parent, which is order, will have multiple product child details, and the entity mapping will be like the parent class, which is order class, will have list of product, and it will be mapped with one to many annotation. And there will be another annotation. Before discussing about that, let's see child to parent relation first. So individual child, different children will be associated to a specific parent, but the only take here is we are not going to configure the parent object, the order object reference in the child class. So the product class will not hold any order object. Instead of it will only hold the order ID. And if you observe, there is no @join column annotation, even though this product class contains a foreign key relation. Rather, this join column will be added to the parent class. That is the only difference. Let's see an example. I will use the same example as I was using while discussing about springFox Swagger 3 configuration with Spring Boot application and H2 database configuration. If I go to my pom.xml, I only have 5 or 6 dependencies related to Jackson Core, H2DB, Spring Boot Starter, Lombok, Spring Data JPA, and Test and Web. Very simple dependencies. If I go to application properties, we only have H2 database related configuration and some log trace related configuration. We will go through the other files, but let's start from the product class. And while preparing the order class related uh, stuff, we will go through the other service and DAO layers which is already available. So now we will create a order entity under entity package, and I'll copy paste all the class level annotations from product. Okay. And it will grab an order ID, amount, order date of local date type, and list of products. We will not concentrate on those annotations for now. It has list of products. In unidirectional mapping, we will use one to many annotation and @join column with column name equal to order underscore ID. That's it. And of course, we will change the table name to orders. And similarly in the product class, what changes we have to do is like, we will have only order ID. We will also add a column name order underscore ID. The service layer for order and the DAO layer will be pretty much the same. So I will copy paste the product service and the product DAO for order service and order DAO. All right, the order service class is entirely copy pasted. But we have dependency. Instead of having dependency on product DAO, we will have a dependency on order DAO. So let's create that as well. We will have order DAO, and we will change it to order type integer. In order service also, we will do the constructor injection. Now we will replace all the product by order. Okay. So by using required R constructor provided by Lombok, and by using this private final keyword, we did the constructor injection for order DAO inside order service, and the same constructor injection we will do in the order controller as well. So let's see that. And to create an order controller, I'll copy paste the product controller which is already available, and it has very basic CRUD operation related methods. Okay, and I'm also using the JPA repository provided inbuilt functions to find, delete, find all, or update operations. So I don't have any explicit methods as you can see in the DAO layer. So now let's create the controller, order controller. And we will replace product service by order service. Order service. We will also replace all the product occurrences by order. Okay. So what we have now, save update order endpoint will only insert only one order at a time. Save update orders will insert list of order. Delete order will delete only one order by this order ID path variable. Delete orders will delete all the orders from the table. Get order will help us to find a single order details. But hey, we don't have any method to get multiple orders at a time, right? Or to get all the orders at a time. For that, we will create another method called get orders. The method name is get orders. We don't need request parameter. We'll create a get orders method in the service layer as well. And this will not need any request parameter as well. List of, and here we will send a custom response called order response instead of sending order. It is a good development practice. Instead of sending the entire entity back to the browser, or instead of grabbing the entity as a payload, we should use order request and order response class for that. Okay. We don't have order response class yet, but we'll create one in the DTO package. We'll create a DTO package now. Under DTO, order response with a class. And we will implement this class by serializable. And we will use Lombok provided setter getter annotations, all are constructor and no are constructors. And this class will hold all the variables exactly same with order class variable. So we will copy paste all this variable. Of course, we will not use column annotations in response class. This is not an entity. So let's do that. Okay, so we have added all those variables, and we also added JSON format annotation to tell the JSON serializer that hey, we need this local date in the JSON response as YYMMDD format. Also, we have added Lombok provided annotations. Okay, so this is how it looks like. Let's go to order service and let's implement uh, the business functionality. For that, we need first we will grab all the order details. For that, we have order DAO dot find all. Now we will validate if this list of order is empty, then we will send an empty list. Otherwise, we will convert this list of order to list of order response. Let's see how to do that. Collection utils under Spring Framework is giving isEmpty method. We will make use of that to check list of order is empty or not. If it is empty, then we will return collections. We will return an empty list. It's under util package collections dot empty list, and then we will use stream API to iterate individual order, and then we will pass it to order response. Order ID, order amount, order date, probably there is another one, products, and we will stream it to a list. We will collect it in the list. Okay. Yeah. So the service implementation is ready. Now let's see the controller. We are getting the order service dot get orders, and we are returning list of order in the response entity, right? So let's change that. So this is how our controller is also ready. Now let's test it in the Swagger. Okay, let me check whether my application was not running. So let me restart the application and reopen the Swagger. Okay, the application has been started. And Swagger is also coming. Order and product controller is also coming. Let's save the orders because we need to insert the parent details first. So we are inserting order detail first. This is the first order. This is the order insertion operation, so we don't need order ID. And product all details also not required. So only this much of JSON we need to send. 200. Let's save. Status is 200. Let's save the product details also. We need order ID because it's a foreign key. Product ID not required because we are doing insert operation. Let's add one more. $200 response. Let's open the S2 console. Password is 123 as we have configured in properties file. Order is fine. Product is also coming fine, and we also have the foreign key coming. All right. So to check the unidirectional mapping is working or not, we will execute get order endpoint, get orders endpoint. Start as 200 and see individual order has list of product details. Okay. So this is how one to many unidirectional mapping is working. Now let's quickly talk about bidirectional mapping and the structure. The hierarchy between the the parent to child entity will be like one order having multiple products, and we will use one to many annotation in the order class. In the parent class on top of list of product details, and on the other hand, child to product relation wise, if we say multiple child will refer to the same parent, so multiple product will refer to the same order, which is order 1. And entity mapping relation wise, the product class will have an order object reference with many to one annotation. Also, we will add at the rate join column annotation, because in bidirectional mapping, we need to add join column in the child class on top of parent class object reference. And the very important thing is we need mapped by property in one to many annotation, and this is how we are achieving bidirectional one to many relation. In mapped by property, we need to add the object reference of parent class, which is added in the child class. So order, which is added as a object reference, single object reference in the child class, which is product, that object reference must match with the mapped by property. That's it. Let's see the example and understand a bit more. So let's quickly go to the order entity. Unlike unidirectional relation, we do not need join column annotation in the parent class or in the order class. We just need one to many with mapped by property. And this mapped by property will hold the object reference name given in the child class. So instead of int order ID, we will use order type order. Okay. This is the object reference. And here instead of column, we will use join column. Join column name is order ID, which is fine. Also, we will add many to one annotation. Okay, very simple. Let's restart the application. All right, the application has been started. We will refresh the Swagger endpoint. So let's save parent class details, parent entity details. Okay, 3 order details I'm inserting now. Insertion is successful. We will insert product details now, which is the child details. All right. We will add the JSON. And if you observe, we are not directly passing the order ID just like a product name. Rather, this order ID is now added inside order object. Why? Because instead of integer order ID, now we have the entire order object reference in the product class. So accordingly, we need to modify the JSON structure in the payload, and we will execute. and the status is 200. Let's see in the S2 console. Okay, foreign key column is also coming. And the parent class is also coming. Now we will see how this bidirectional one-to-many is impacting on the JSON response. So for that we will execute get orders endpoint and execute. Oops, we got one error. Let's see in the console what is the error we have. Let's closely observe what is coming up. All the errors are coming from faster XML Jackson. And the reason is Stack Overflow error. Why there is a Stack Overflow error? Because while we are doing the one-to-many bidirectional mapping, so we did like in order class we have list of products, and in product class we have one order, right? So when Jackson, faster XML Jackson, who is the deserializer for our case, when he is trying to deserialize, okay, he is getting inside an infinite loop. So for example, when we executed get orders endpoint, it found a list of products. Individual product has order detail. Again, individual order has list of product detail. Again, individual product has order detail, and so on. So it turned out into an infinite loop, and ultimately a Stack Overflow error has come up because it ended up in an infinite loop. So to resolve that, we have to add few special annotations in the parent and the child class. The annotation is JSON manage reference and at the rate JSON ignore in our parent class. And in the child class, we will use at the rate JSON back reference. So we are telling our faster XML Jackson, who is our serializer and deserializer, that hey, when you are finding the list of product details, ignore the list of product. And when you are finding the order detail, manage the list of product, which is coming inside. And let's see how that is coming in action. Okay, application has started. Let me re-execute this endpoint. So I didn't refresh the Swagger. So at least it is giving 200. Let me quickly insert the parent details. Parent details added. Let's insert the child detail. Child details added. We'll execute the get orders now. Okay, this time it is not throwing any error. We are getting list of child details inside parent. Okay. And but this is still one way relation, right? We only saw the child details inside parent. But if we could somehow see parent details inside child, then we can say that, hey, this is bidirectional relation, right? So just like get orders endpoint, we have to create get products endpoint, and we will test it out to see whether the bidirectional is working fine or not. So I'll simply copy paste the details. Just like get orders, we'll have get products inside product controllers. And we have product response instead of order response. Obviously, we have to create this class, and of course, we have to create get products method also. And the business functionality inside get products will be exactly same that we have configured in get orders. So I'll copy paste and do some minute changes. Instead of list of orders, we will have list of products. We have product find all. Then instead of orders, I'll replace it to products, and we will take individual product, and we have not yet created any product response, so let's do that first. In DTO, we'll create a product response class. Again, I'll copy paste all the class level annotation. It will also implement serializable. Okay. And the variables in the product response class will be exactly same with the product entity. So I'll copy paste that as well and remove the Hibernate annotations. All right. So let's import this class as well. We'll change it to product response. We don't have this many properties, right? Product dot get product ID, name, get order. I think that's it. What else we have in the controller? Okay. So far so good. Let's restart and test it out in the Swagger. Okay, application is running now. Let's refresh the Swagger. And of course, we will insert those details again. So feel free to skip this part. Order got inserted. Let's quickly save the products as well. Okay, product also got inserted. Now we will test get orders just for confirmation. Okay, list of products inside the parent order detail is coming fine. Similarly, we also have a get products endpoint. Now when we test it, we are expecting order detail, single order detail inside each product details. Yes, it is coming, but wait, this order date is coming in array of comma separated thing, right? So I think we forgot to add that JSON format annotation in the product response class. I'll keep this part to you guys. Just to add this annotation. Okay. Probably we need in this entity itself because we are directly mapping the entity. So JSON format annotation you have to add in the order class itself. and give me comments and tell me how it is coming up. So thank you so much guys for watching. So today we understood what is unidirectional one to many relation and bidirectional one to many relation. Stay tuned for more videos guys. Thank you so much for watching.